come back to the modern periodic table again to see the difference and similarities between Mendeleev's and Moseley's periodic table. According to Moseley, he studied the emission spectra of many metals, and he was able to conclude or summarize from that data. He was able to say the pattern of the emission from the emission spectra tells that elements are arranged in increasing. If elements are arranged in increasing order of nuclear charge, it would be a very nice pattern. So that pattern will display it later in terms of atomic number, because nuclear charge means the charge of the nucleus is because of number of proton. So as we have said here, in this part, the halogen part, they were ignored at the beginning because they are very inert, very stable, chemically stable. So they were ignored since they are chemically stable. So because of the Ramsay, so he was able to determine their existence. So helium was determined, neon, argon. After they were discovered, Ramsay put them at the last group, or group 18. So right after group 18, you go back to group 1. So if you are using this relation, you can have periodicity. So if we see helium, to get helium similar property like helium, which is neon, you should count 1, 2, 3, 4, 5, 6, 7, 8. So the difference after 8 elements, you will have another similar property. And again, if you go to here, you will have 1, 2, 3, 4, 5, 6, 7, and every 8 again you will have another. And if you count this one, it will be 18. It will be 18. Now it is period 1. This is 1. This is 2. This is 3. This is 4. 5. And 5, you can see a relation again, which indicates 18 again. So between helium and neon, there are difference in atomic number is 8. From neon to argon, the difference in atomic number is 8. From argon to krypton, the difference is 18. From xenon to radon, the difference is 32. You can check, because here you have in period 6 you have the lanthanide. Don't forget this. That's why it becomes 32. You can count from here 57, then 58 comes here. That's why the difference becomes 32. The same difference is observed between, again, lithium, sodium, potassium. So between the atomic number difference between lithium and sodium is 8. It is 311. 311, 8. Again, 11, 19 is 8. And this is 18. The difference is 18. And from here from cesium to francium, this is again 32. So this tells us the periodicity at 8 intervals, 8, 18, 32, you will have the same kind of element. Like same kind means in behavior. The same is true here. We will observe similar behavior with after some intervals. So this is what we call it periodicity. Periodic. It exhibits periodic property. So we are going to define what periodicity or the periodic law. Um, Before that, as you can see here, elements are arranged in using increasing atomic number. There is no anomalous situation that we have observed in Mendeleev's. So it was iodine here, tellurium here. Look, one of the discrepancy was here. If things are atomic number arrangement, mass number arrangement, it should have been in this way. So, according to Mendeleev, when he arranged elements based on their atomic mass, it should be iodine was lighter, has less mass than tellurium, so it should have been switched. But if we make this thing using atomic number, everything will exactly fit in the pattern. So they fit into pattern better when they were arranged in increasing order according to nuclear charge. So arranging elements using nuclear charge is the best way, so that we can avoid every anomalous behavior. So this is one. So whenever you have atomic number, so things can be arranged in this way. So his work, Henry's work, ends up in Henry Moseley. He was able to define atomic number. At the same time, he considered atomic number are the bases for arranging elements. In the periodic table. So another important point regarding this group 18 elements, these noble gases, for the first time Sir William Ramsay discovered helium. Argon is also discovered in collaboration with John William Sturt and Ramsay. And remaining two, like krypton and xenon, is also discovered by Ramsay. And finally, the radon is a German scientist, Frederick Ernest Dorn. Then after we have a complete set of noble gases, William Ramsay introduced a new group to the modern periodic table. So this is introduced, the new group is introduced by William Ramsay after the discovery of these noble gases. And the other important point, the actinides and lanthanides. This is lanthanides and this is actinides. Since lanthanides have got a very close similarity among each other, separating them was a difficult task. So they are placed from 58 to 71. The reason they set off from these, the main body of the periodic table, just to save a space. So the next discussion will be on